Question 48 asks, far in space where gravity is negligible, a 425 kilogram rocket traveling 75 meters per second in the positive x directions fires its engines. We have a graph that shows the thrust of the force as a function of time, and it wants us to know what impulse does the engine impart to the rocket and what time does the rocket reach maximum speed and what is the maximum speed. So what is the final velocity? Okay. So, looking at it here, here's our graph. We have our rocket. It has a maximum thrust of about 10 seconds and 1,000 newtons. And then the thrust starts decreasing at 30 seconds, and then the rocket just stops. So, it's asking us first thing, so what is the impulse? So, impulse, I have delta P equals force times change in time. Or impulse is the area under a force versus time graph. So the area underneath it here, we're just doing 1/2 times 1,000 times the base, which is 30 seconds. So that is 1,500 newtons per second, or 1,500 kilograms times meters per second, however you want to look at it. So the next question it's asking us is, what point in time does it reach the maximum velocity? So we're going to answer that in a second, first by just calculating the final velocity. So we know, again, another formula for change in impulse is going to be momentum, so mass final times velocity final minus mass initial times velocity initial. So we rearrange that to solve for velocity final. We're going to add this to this side and divide our mass. So we just calculated our impulse. It's 1,500 kilograms times meters per second, and then we're going to add that to our initial mass plus times our initial velocity all over our final mass, and these two numbers are actually going to be the same. So coming over here, we are looking at 15,000 kilograms times meters per second plus 425 kilograms, the mass of the rocket, times 75 meters per second. And then we divide that, and so our final velocity is 110.3 meters per second. So initially it was asking us at what point is it going to have the highest velocity. So looking at the graph here, you would say, well, probably about 10 seconds, because 10 seconds is where the force is the highest. However, that's not the case, because as we can see here at our 30-second mark, we went from a velocity of 75 meters per second to 110.3 meters per second, even though at 30 seconds our force is 0. So to answer that, 30 seconds is where we have the highest velocity.